On August 11th, my boat trailer on this side broke an axle. And the axle broke at the bottom, even though the area looked pristine in terms of the type of coating it had on it. And when it did that, it allowed the tire to twist in this direction, come up this way, and trap the fender against the side of the boat. So as we were going down the road, all the weight was on this tire to be pushed into the side of the boat through the fender, and it gradually burnt a significant hole in the side of my boat. Unfortunately, and I take pictures of everything, I didn't take pictures of this mess. I think deep down I really didn't want to remember any of this, because I was just certain that the boat was ruined, I wouldn't be able to fix it, and I'd have to scrap it and buy another boat. And there's only a few weeks left at that point in good boating weather in Maryland. So the fender initially fit like this on the original installation before the accident, before the axle broke. And so when it got trapped, the fender was pushed up like this against the side of the boat. I kept the fender just because I really don't throw anything away and I didn't know what else to do with it. But now that I did, maybe it's interesting to take a look at what we have left here. So you can see the tire residue stuck in the molten fender at this point. Of course, this all broke loose, and some of it's still just hanging down like that. And from the inside, what's supposed to be the inside, most of that's missing. This was all one piece to protect the boat from whatever the tire would throw up as it went down the road, and it's all gone, of course. And you can see how molten it was and how it finally dried in place. Now the boat is made of something called Roplene technology, which is just another name for one of the family of polyethylene chemicals, plastics, that is called high density polyethylene, and you see it it's made in to make milk cartons, bottle caps, cutting boards, a lot of things that are used, they're made from that. But this boat is made from that, and so it's not fiberglass, and so repairing it is a different story. And the rest of that story tells you in this video how I got from where I was when this happened on August 11th to where we are today. When I got the boat back home again and cleaned off the melted pieces of fender that were stuck to the side of my boat, or what was left of the side of my boat, I decided maybe things didn't look as bad as I had thought to begin with. There didn't appear to be any structural problems, although I can't be sure about that because I can't see the inside of the boat on this particular boat. But it didn't appear that there was any reason for water to leak in from my inspection of what was left. As you can see, there's a shape there, sort of a round shape as you would expect if a tire got to run against the side of your boat and just melt whatever it came in contact with. And that's what had happened here. So I decided maybe I'd give it another look, and maybe there was some way that I could repair it, but I didn't know anything at all about how to repair high density polyethylene, which is what this boat's made out of. And if it had been epoxy and fiberglass, then I would have known more about what I was doing, but this was a little out of my league, and so I was going to have to do some research. So the first thing I had to do was do some research on Hdpe. That's high density polyethylene, and it's the same stuff that has a recycling triangle with a 2 in it on the bottom of your milk cartons, bottle caps, etc. Best place to look for me was YouTube clips, my go-to opportunity for learning things I don't know anything at all about. And I found that there were some really great clips for making things from Hdpe. And I'll leave links in the description for the ones that I reviewed. But just search on Hdpe or plastic welding and prepare to be really amazed and impressed. There's plenty of information on how to make things out of recycled materials made Hdpe. But there's nothing about how to repair an Hdpe boat, and that's what I have, is an Hdpe boat. I discovered that you can buy HDPE sheets like this. This one's 3/4 inch stock. I have another piece here that's 1/4 inch stock. And this one was a lot bigger when I started, before I started this experiment, and there's obviously a lot of waste when you don't know what you're doing. The color appeared to be close to white on the boat. Whites are never exact, and when we go out to look at the boat later, I'll show how that's worked out for me. So I set out to see if I could replicate the techniques from YouTube using plugs I made from the manufactured panels. The YouTube clips seem to dwell on using a waffle maker, and I happen to have one. And this has got the waffle part showing, but I use the opposite side. If I could figure out how to get it out of there.
Push the clip down and pick it up.
Here we go. Here we go. You see, I only use this for one thing. I don't make anything. And so I used the flat part and I lined it with parchment paper, which actually is pretty good for one-time use to keep the HDPE from sticking. So what I did, I took a piece like this and I put in it and I propped it down and cranked her up, and it went up to about 350 degrees plus. The internet says to use 350, but I didn't have anything accurate to set it for that. But when I turned it all the way open, I did put a probe on it and discovered it went up to 428. So we put this piece inside and put the parchment paper on there to protect the waffle maker. And I need to give you a caveat here, because this waffle maker doesn't work very well for waffles anymore after I did this. Even though I protected the surfaces where you make waffles, it sticks now bad than it didn't before. And I assumed that heating it without anything in it but a small piece of plastic was not the right thing. But anyway, that's what we did. And so when I got done with a piece like this that I melted under pressure on the waffle maker, it came out looking sort of like this. I'm just showing one side. Notice it's cut off here. It used to be longer than this. And part of my experiment was to find out if I could make puddles like this, which you can find on the internet when people are using milk cartons all ground up, out of the already manufactured stuff. So I cut a piece off, and here's the other side of that piece, and I had to find out if I could stick these two together using similar techniques. Now keep in mind, nobody on the internet was trying to stick them together this way. They were making flat sheets to make out of coasters and things like that. Really neat stuff. You need to look at that. It's impressive. But that was my plan, was to make my plugs so that I could stick them into the hole in my boat, get them hot, and get the boat hot, and stick them together. And this is what I did here. So it appears that the HDPE material I bought works pretty much like what I saw on the internet. So I'm sort of encouraged that this might actually work. Next, I had to cut the sheet stock into plugs that I would heat and press into the hole left by the tire. I won't be using this anymore because I'm working with 3/4 inch stock, and I want it to stay 3/4 inch, except for whatever little bit squeezes down to another size when I force it into the boat. So we don't need this anymore. And to get smart enough to do this, and I'm not sure I was totally successful with that either, I made my first examples out of wood. I just used my bandsaw and a belt sander, and I kept playing with it and cutting off things that seemed to get in the way until I had a rough shape of what I thought the plug should look like. After that, and this is why the pieces of this are gone, because some of this didn't work for me, and it's not exact science, but I did manage to make this piece. And you'll see when we go back up and look at the hole on the boat why it had to be shaped this way. But this is the curve left when the tire got finished with it, right down at the water surface. And then at this end it'll be pretty much straight. So this is how it came out from that experiment. And the screw in there, so I have something to maneuver it by when it's kind of pliable and hot. I have hot gloves, so that's not a problem. I made the patch this size even though it really needs to be about this size to fill the hole completely, because my skill set won't allow me to do great big things like that, and I don't want to have to buy another piece of this stuff before I get started on this thing. So I settled for making this relatively large one, and I'm going to complement it by smaller ones until the void will be filled. Now, for the purpose of this video, I'll probably just show how this goes in and demonstrate that it sticks, if it actually does stick when I'm done. I won't bore you with all the filling it all and plastic welding that I was doing after that. Also, I suspect that the allowable time for sticking the plugs in the boat is finite, with little time to fool around if something doesn't exactly fit. If it gets stuck wrong, there'll be no way to get it out again. This is the patch area after I cleaned it all up and got the fender all unstuck and cut off. This piece of stainless is to provide a floor for that, the place for the plugs to sit on, so that they will be flush with the bottom of the boat when this is over with, at least in theory. This is stainless steel. It appears that the Hdpe does not have an affinity for sticking to metals once it's not sticky anymore. So once it cools off, maybe I'll be able to get this back and it won't be on my boat for the rest of my life. This would not be a good time to catch the boat on fire. We have a extinguisher over here handy. I'm going to show you how the piece is supposed to fit. Now this is the piece we talked about before. It has a screw in it, and it's supposed to fit right in there. These marks line up with the boat, and just like that. Okay, once it's all hot and sticky, and the boat's hot and sticky, we'll press that into place. And then, everything's out of reach today, I'll take this piece and set in front of it for a press. So this is the clamp that I made to try to hold that in place. Hdpe is very bad for warping as it dries, and I would need to clamp it in place. I think there's enough structure there in the boat to hold it in place, but I'm going to do this anyway. And I made up this press for it with my new hub on my new axle, but without a tire that would be in my way. And the way this works is this whole mechanism tilts up like this, and then this screw, this ball thread goes through there like that, and you tighten it up with a nut so that it takes the pressure on it and pushes this against the thing that we're trying to glue into place. We'll see how that works. Okay, so here's the setup with the toaster oven here, the piece that we're going to heat in the toaster oven ready to go in, setting on a piece of aluminum, and we'll just close that up and turn it on and let it cook for 20 minutes, and I'll stop the video. I won't have you sitting here trying to watch that heat. One thing you'll notice with this piece of manufactured sheet material is that when it gets hot, the margins of it on the periphery get transparent, and that's about the time when the piece starts to droop and turn into a puddle. I didn't notice that on the YouTube projects where they were using recycled materials, and I didn't notice it during the cosmetic work that I've already done on my boat whenever I would gouge it or ding it somewhere along the way. The good news is that this white, that seems to be unique to this process, this clear part, turns white as it cools off. As you notice, this will turn now, and it'll become white again. So that's the good news. You don't want to, for what I'm doing, you don't want to let this get to this point where it changes shape, because I need for the shape to stay consistent. I need for it to be a little bit pliable so I can squeeze it into irregular spaces, and I certainly don't want it to stay clear, but it doesn't appear that's going to be a problem, because as you can see, it's turning back to white again. There are two heat guns involved here. There's one over here that'll be used to heat the inside of the cavity, and one over here, I'll walk in front of the camera, they'll be used to heat the plug after we take it out of the oven. It'll be just post-heating. It'll already be almost hot enough, but this will put the finishing touches on it. And when the oven's finished, Sandy will take these pliers, take this out of here, set it in there, and then when I get done heating over here, about the same time that she's done over there, I'll just reach over with my hot glove. I'll put one on right now just because they're kind of pretty and they cost a bundle. And I'll just reach over and grab this piece here and slide it in there and push it into place, and then I'll go through the press part of keeping it there. And that's pretty much how it's supposed to work. Got the fire extinguisher handy. I don't think this stuff will catch on fire with what I'm doing, but we're at least ready. Well, when both the plug and the phone and the boat are starting to get sticky, we'll press it in finger tight. Now I don't know how thick the remaining skin of the boat is or how strong it is, so I don't want to push this press here. I don't want to punch it through into the rest of the boat, so I'm going to be careful with how much tension I put on. We'll let it cool and start fabricating the next plug. We have never done this before and may not do it again. The next few minutes may be too hectic for dialogue, except for us keeping up with each other. I try to script these videos, but there is no way to predict how this is going to work ahead of time, so there's no script for this part. If the boat catches on fire, I can just edit out the audio part that would likely keep my videos off of YouTube for a very, very long time.
I can't tell if I'm doing anything or not.
Me neither. I think mine's getting ready, but I don't like what I'm seeing here. You're not soft yet.
I think it's making a puddle on the bottom.
Okay, get ready. I'm going to turn mine off. Take yours. Dear, I think that was perfect. Still on? Well, it looked pretty good. It'd be time to figure that out after it sets up and I'll get to take a look at it. Everything worked out exactly the way I'd hoped it would, but I didn't know what I was doing anyway, so who knows if that was a good idea or not. The plug that I put in was soft and malleable enough that it would give when I put it in there, and the glue was running out of the bottom of the plug, and the boat polyethylene was starting to drip. I don't think I can get any closer than that, so we'll see how it works out. As you can see, the patch part of this project is pretty much complete and seems to be working out about the way I intended for it to. There's still some auxiliary cosmetic stuff going on here from when the fender was flapping around against the hot side of the boat that had been partially melted from the tire. And once it settled, of course, that damage didn't go away. So I'm going to try to fill in some of these cracks here and sand it again. It's been sanded once to make it get down to this point, and I've used this technique to filler some of the holes and gouges once already and sanded that down. I'm going to have to do that a couple more times, and in order to accomplish that, I made some kind of rough welding rods. I took some of the 1/4-inch material and cut it thin so that it'll melt easily, and I'm going to try to chase this across here with the heat gun and melt it into these voids, and then put a block of aluminum on top of it to pack it in until it cools, to try to make it stay where I put it. So that'll be the next thing I'm going to try to do here. Now the trick here, if there's a trick to it, is to heat the end of this until it gets transparent. Remember, we talked about this before, it'll go back to white again for the manufactured Hdpe, but it doesn't do that for the rest of the boat, but that doesn't seem to be a problem because it goes back once you get done with it. So we'll melt this until it starts to puddle. First it gets shiny and then it starts to get transparent, and the very edges, if you look here very closely, the edges are already getting kind of transparent. I'll have trouble keeping this all in focus. I'm going to start with this gouge right here across the top. You won't see this anywhere else. This is an idea I came up with, and I don't know if it's right or wrong, but it seems to be working sort of. Now I heat the boat and this piece that's already there and try to get it stuck. Then I move up the rod, start softening the rod some more. Of course, wouldn't you know that I'd pick a short piece of rod and it's already, the air off the gun is already getting to my hand, so I'm going to have to wear my fancy colored gloves for this. You notice how this is pretty much stuck here. It's not totally stuck, but it's getting there, and this is where we want it to be. And now I'm going to try to draw this bead out here across this notch as far as I can. We start heating again. Oh, notice that it's, the part I started with is already turning white. So now I'm going to heat this. I just keep pulling on the rod. If I pull it fast, and I get a skinny bead. If I pull it slow, I get a fat bead. Now comes the hard part. I have to cut this bead. I was going to use a pair of my wife's sewing scissors, but she said no. Okay, and we have some stuff pushed out here. I'm going to try to mash it down a little bit while it's still gushy, and push it into that space. Now you see, this is already hard here. Now that's not the end of this. I believe that the air off the heat gun helps push the bead into where you want it. So this works okay this way. I think it works okay if you're working up and down this way. When I get around to the bottom of the boat, I may be in trouble with this technique because I don't think it's probably made for that. But when I'm done here, I'll heat all of this, and then I'll put a clamp on this to make sure that it stays tight until it's cooled out and I'm ready to go on and try to sand it. It's really amazing stuff. You look at this piece here, how it's really you'd think it would just crack right off of there, but it's strong. I need to heat this up so that it gets pliable enough that I can squeeze it with my press. And you may wonder, well, why don't you just do the whole thing at once? Well, I can't keep it all hot at once, is the problem. You see the boat getting soft there? Okay, time to put the press in. This part here is that last patch that we just filled in after the press. There's then we'll sand this down and take it down to the same level as this and hope for the best. Okay, I've done a couple patching cycles and some more sanding along the way, and it's down pretty smooth. There are a few pieces here that don't look so great, but what I've discovered here is that the color of the manufactured sheet that I was using is not exactly the same as the boat itself. And I think this dirty looking place up here is from me mixing the manufactured stuff with the boat stuff, and now so it just looks dirty, but there's probably nothing I can do about that. I wasn't able to match the white very well, and I think that this is just what happens if you squeeze all that gray white stuff into the white stuff, and it just changes color. But it's about as far as I'm going to take it for now. I may decide to come back and try to shine this up a little bit. This is sort of scratched from sanding and whatnot, and so it won't shine again. But this part's probably below the water when I'm just cruising along anyway, so it probably doesn't matter. So that's about all I'm going to do on this part, and the bad news for me is that now I have to go underneath and try to make the patch from the underneath look like this patch does. If I get it looking this good, then I'll be done and I'll consider it a huge success for me. But that's where we are right now. Well, this is what the patch looks like from looking at the side of the boat and the bottom at the same time. You'll notice that I didn't waste a lot of time on smoothing the bottom part because it sometimes seemed like I was destroying more than I was fixing with the sander. So I just carefully laid the beads and let them pretty much stay where they were. This is probably the end of this part of this discussion. So I'm going to go ahead and put the wheel on and maybe I'll go fishing.